What we perhaps have noticed in this chart is how atoms form ions to achieve a noble gas configuration. For instance, if sodium atom 1s2, 2s2, 2p6, 3s1, the noble gas we last passed through is a noble gas neon. So in brackets, the neon represents the first 10 electrons of sodium. It's the goal of every atom to become like a noble gas. Sodium wants to lose that 3s1 electron. When it loses that electron, it becomes a net positive charge and now has the configuration of neon. Magnesium, who lives right next door from sodium, has 12 electrons. It's number 12. First set of electrons fill the first 10 here of neon. In this bracket, I really see 1s2, 2s2, 2p6. That gets me the 10 for neon. 3s2 lands me at magnesium. If I lose those 2 electrons, it now carries a +2 charge and goes to form neon. Same is true for aluminum. The trend says if I have 3 valence electrons, it will become a +3 when I lose those electrons, again going back to neon. Up above in period 2, we see the nonmetals oxygen and fluorine. Oxygen, last noble gas passed through, is helium. We're in the second energy level, 2s2, 2p4. It's easier to gain 2 electrons to fill that second energy level than to try to lose 6. Gaining 2 electrons now carries a -2. Here it called oxide, now having the same configuration as neon. Fluoride will gain 1 electron to achieve the noble gas arrangement of neon. Sodium ion, magnesium ion, aluminum ion, oxide, and fluoride are all isoelectronic. They all have the same number of electrons, which there indeed matches neon's 10 electrons. They've either lost or gained electrons to achieve the noble gas configuration. So atoms will bond because it results in a more stable configuration. More stable means lower energy level. Atoms bond together by either transferring or sharing electrons, and usually this results in all atoms attaining an outer shell with 8 electrons. This is known as the octet rule. Magic number 8. Remember, every atom wants to become like a noble gas. Although there are exceptions to the rule, the vast majority follow as we create compounds, join together atoms to form molecules, so we arrange electrons to achieve the noble gas configuration. So that octet rule says the valence electrons of a noble gas, S2P6, where N just represents the period number, the energy level. Noble gas configurations have 8 valence electrons. Now there's many exceptions, those atoms that become like helium. Helium is a noble gas with only 2 electrons. Hydrogen, lithium, beryllium, boron all become the noble gas like helium. So therefore, it will have a duet, not an octet. Lithium, when it goes from a lithium atom to a lithium ion, has 2 electrons, just like helium, and so forth through this slide. Beryllium loses 2 to become like helium. Boron loses 3 to become like helium. Sometimes we have to expand an octet for the elements in period 3 or below. If we see empty d valence orbitals, we are allowed to expand the octet. Silicon, phosphorus, sulfur can place those in the expanded octet in the d sublevel. The s orbital has 1 spatial orientation. The p has 3 spatial orientations. Recall that the d has 5 spatial orientations. Sometimes we can promote the p into an empty d orbital. That's what's known as expand. Again, very rare. It's just kind of sharing that, and we'll do a few examples toward the very end of the chapter when we are told to expand the octet. Let's consider the Lewis theory with ionic bonding, electron transfer. And we've just modeled this one a moment ago. If I have a metal, lithium, and a nonmetal, like fluorine, lithium's configuration shows 1s2, 2s1, one valence electron gets one dot. Fluorine lives in group 7a, 7 valence electron. Its configuration would end with 2s2, 2p7. Everyone wants to have the noble gas arrangement. Lithium, if it loses its electron, and fluorine, if it gains the electron, transfers this, forming what's called an ionic bond. The electron transfer from the lithium to the fluorine creates an ionic compound, where lithium now is like helium in configuration, and fluorine becomes like neon in its configuration. The name of the compound formed is a binary ionic compound called lithium fluoride. Taking the dot from the metal and giving it to the nonmetal. We practiced many of these last quarter. I think of this as just, if I wanted to know, predicting for ionic compounds, it's just crisscrossing charges to find how many of each we need to create a neutral compound. So the ionic bonding, according to the Lewis theory, says, I predict the number of electrons a metal atom should lose or a nonmetal should gain in order to attain a stable configuration, aiming for the octet rule, become like a noble gas. It allows us to predict the formulas of our ionic compounds that result. By just crisscrossing charges, we can come up with our formulas. It also allows